So thank you, everyone. Good evening and welcome to the Victorian Renewable Energy Terminal Community Information webinar. My name is Lyndall McLennan and I'm going to be hosting tonight's presentation. Now, before we start, I'd like to acknowledge the traditional owners of the lands I'm calling in from, the Wurundjeri people. I'd also like to acknowledge the traditional owners of the lands that the Victorian Renewable Energy Terminal is proposed to be built on, the Bunurong people. We pay our respects to the elders past, present and emerging. And if you wish to, I also invite attendees to acknowledge the traditional owners of the lands from which you are also joining this webinar this evening. You can do that in the QA function. So thank you for taking the time to join us this evening to hear about the Victorian Renewable Energy Terminal and the technical assessments we have underway for the project. We have a range of specialists and project team members presenting tonight. But before we start proceedings, and I do walk through the agenda, which you can see on the screen, I'd just like to share a few housekeeping notes. We'll be having a dedicated QA after the project presentations, where we will answer as many questions as we can get through. At any time throughout the webinar, please type your questions into the QA function, which you can find at the top of your screen. I think you also should have access to a chat function, but we're encouraging you to use the QA function just to log any questions that you may have. You can also upvote any questions by clicking the vote button. And I'd also like to note that all questions that you're going to ask tonight will be public to everybody in this forum. So please ask your questions respectfully and just acknowledge that this is a public forum. If you're having any technical issues tonight, please try refreshing your Teams window. And also you can, of course, come back and rejoin the session as well. I also just want to take a note, we are experiencing some stormy weather here in Melbourne tonight, and this may be affecting the power and the internet connections, both for our technical team, but also for our presenters tonight, and also for all attendees as well. So if at any point there is a loss of connection, particularly for our port technical team, we will finish the presentation early and find an alternative way to respond to your questions. But hopefully this is not going to occur, and I do think the storm may have passed and might be just affecting some other parts of Melbourne at this point. And a final note to say that this session is being recorded and will be uploaded to our project website. So on the screen, we have our agenda for tonight's webinar. The first presentation will be an introduction and project update from Peter Watts, our project director at the Port of Hastings Corporation. Peter will then share some specific features and elements of the project options being considered for the project and the work that we have undertaken to understand construction and operations of the terminal. Following this, Natasha Reischneider, the project's approval manager, will present on the environmental assessment approvals for the project. David Christodoulou, the project's construction manager, will talk through the construction methodology and approach for the terminal. We will then hear from our technical experts on the studies underway informing our environmental assessment process. We will hear from Dan Mestier from Royal Haskonian, who will talk through the coastal process assessment underway. We will also hear from Chantal Steele, the Port of Hastings environmental manager, on onshore ecology studies taking place at the terminal site. We will then finish with a presentation about visual and landscape amenity from Hayden Bergs from Landform Architects. Following Hayden's presentation, we will move to questions. I will now hand over to Peter, who will start this session off with a short animation.
The Victorian Government is establishing a thriving offshore wind industry, paving the way for our state to host the first offshore wind energy projects in Australia. Wind blows much more consistently out at sea, and Victoria has some of the best offshore wind resources in the world to support a clean energy future. The Port of Hastings has been selected as the location for the Victorian Renewable Energy Terminal and, subject to the necessary approvals, will become the dedicated assembly port to import, pre-assemble and transport offshore wind components to wind farms in Bass Strait off the Gippsland coast of Victoria. Offshore wind production refers to energy that is generated when winds at sea turn large turbines, producing clean, reliable and renewable electricity. The electricity produced travels through undersea cables from the turbines to a land-based substation, where it is connected into the existing transmission grid infrastructure. To construct an offshore wind farm, supply ships first deliver the wind turbine components to the Victorian Renewable Energy Terminal at the Port of Hastings. These components will be stored at the terminal and include the foundations, towers, blades and power generation units. Some wind turbine components, such as the tower segments, will then be pre-assembled at the terminal before being loaded onto specialised installation vessels for transport to offshore wind farms. The installation vessels will transport and install the wind turbines at their locations in Bass Strait off the Gippsland coast. Each installation vessel can carry and install multiple wind turbines before returning to the terminal for reloading. Victoria's offshore wind farms will produce 2 gigawatts of power by 2032, 4 gigawatts by 2035 and 9 gigawatts by 2040. 2 gigawatts of power is enough to power 1.5 million homes. Specialised port infrastructure is required to support offshore wind construction due to the size and weight of offshore wind components. The Port of Hastings has been selected as the most suitable location for the Victorian Renewable Energy Terminal, with the benefit of having large areas of available land next to deep water channels, proximity to proposed offshore wind farms and adequate channel capacity to manage specialist vessel movements. The Port of Hastings Corporation will develop the terminal in consultation with traditional owners, communities and industry. Together, we can support clean, renewable wind energy for our future. For more information about the Victorian Renewable Energy Terminal project, sign up to receive updates via our website.
So thank you everybody for joining. I see we've got a great attendance tonight. There are over 92 people. There are 92 people. And it demonstrates the sort of level of interest that we've got out in the community and amongst our stakeholders. So it's a great attendance. In terms of myself, my name's Peter Watt. I'm the Project Director for the Victorian Renewable Energy Terminal, and I've been working for the Port of Hastings for a bit over 7 years. With my industry experience, I've got over 35 years experience and have been worked on a diverse range of marine and port projects, both in Australia and overseas. And I must add that this is probably one of the most exciting projects I've worked on. This project is not about building a port, it's about energy security, and it's about that transition to net zero. Being involved in the renewable energy sector, I find particularly satisfying, and I think we're getting great feedback amongst the community for the type of work that we are doing at the moment. It's also a really satisfying time for us to present to the community the body of work that we've been working on for the last year and a half to 2 years or so. So my talk is on the project overview and where we're up to date in terms of the design and layout of the terminal. So for those of you that don't know, the Port of Hastings is located in Western Port. It's about 70 kilometres southeast of Melbourne, and we're one of 4 major commercial trading ports operating in Victoria. The port's been operating for close to 60 years, and it really started off in the late 60s, early 70s, where there were a raft of new developments, including the Crib Point Terminal, the Esso Long Island Point Fractionation Plant, and also the BlueScope Terminal. We've got some really good attributes in terms of a port, and we've got a naturally deep water channel and a lot of available land, which is largely undeveloped, and it's been zoned for port-related use. There's about 3,500 hectares. And what does the port do at the moment? Typically, we're predominantly fossil fuels. We have the import and export of crude oil, condensate, liquid petroleum gas, steel, petrol and diesel. And with this proposed development, we're set to play a key role in Victoria's renewable energy transition. So in terms of where the project is located, it's located to the northern area of where the port operates, and it's sandwiched in between, or the proposed development will be located in between the BlueScope Steel wharf and the steel manufacturing plant. And the steel manufacturing plant is a bit out of that picture, towards the bottom right of the screen. And then to the south, we have the Esso fractionation plant and the Long Island Point liquid berth jetties. So the land where we're looking at developing comprises what we call the Old Tyabb Reclamation Area, or we refer to that as OTRA, that's the acronym. And that's about a 25 hectare area of land, which is shown by within the red dotted line, and that's the green land. We'll then also be looking at reclaiming out into Western Port, and there will also be some dredging works done beyond the area of reclamation. So in terms of the location within Western Port, so we're located where it says number 2, and you can see Western Port, or many of us know that there's a Ramsar site within Western Port. So a Ramsar site is an internationally recognised wetland, which has a higher environmental threshold to get approvals for development. So that Ramsar wetland within Western Port is indicated by the blue hatched area. It's about 60,000 hectares in size, and the location of the port, you can see the little inset blow up of where the port will be. So the reclamation for the port will be will take up about 18 hectares of that Ramsar wetland, which is around 0.03% of the total area of the Ramsar wetland. In terms of the ports, the main port facilities, they're located between, or at those points 1, 2, 3, 4, and 5. And the port, where the berths are, extends over a length of about 10 kilometres. We also have a shipping channel, which goes out, comes in from the Bass Strait and goes through the Western Channel, all the way up through the North Arm and up to the BlueScope facility, which is at point 1. The dredging that we're looking at doing is very isolated, or sort of in a small localised area, and it's up around the BlueScope and just a bit beyond the Long Island Point jetty facility. So this slide shows a render of what the facility will look like once it's constructed. So what you can see there is the storage of a number of different turbine components. So turbines in their assembled state, and in their completely assembled state, and how they would look out in the Bass Strait in the offshore wind zones. They've got blades, they've got tower sections, foundations, and transition pieces. So the Port of Hastings and the Renewable Energy Terminal will be a central staging point for delivery of all these different turbine components, which will come from overseas locations, certainly in the first instance. The deliveries of the turbine components, they come in by ship and they're offloaded off the ship and then stored in the facility. And then there's some assembly work that's done to them. So for example, you can see the tall towers. Those towers come in 3 sections or possibly 4 sections, and then they're progressively bolted together and stood in an upright position. And then when there's a suitable number of components that have come in, then you have the offshore installation vessels, which will come in and might pick up 5 or 6 sets of wind turbine components. It will then sail out to the offshore wind zone, about 220 nautical miles away. It will then do the installation, and then it will come back to the terminal and pick up another 5 or 6 sets of components and continue to transition back and forward between the port. So the port, as I mentioned before, we've got the majority of it is developed on the Old Tyabb Reclamation Area, so it's on existing land. And then we have 18 hectares of new land that will be reclaimed out into Western Port. Good. So next slide. So why Port of Hastings? So the reason Port of Hastings is the preferred location, it was a decision made by the government, so the state government. So state government looked at the 4 commercial port locations and looked at what attributes provided a superior location. And the Port of Hastings was that superior and preferred location. And some of the key reasons why is because we're the closest commercial port to the offshore wind zones. So having that proximity reduces sailing times for the vessels, it improves the logistics, reduces the supply chain risks, and it minimises the length of the overall construction program for the development of the offshore wind. Second item is the existing shipping channel. We've got a naturally deep and wide shipping channel, and it needs like maintenance dredging. So maintenance dredging is to remove any sort of accretion of sediment that happens over a number of years. The amount of maintenance dredging is very minimal and a lot less than any of the other commercial ports. We've also got a lot of land area immediately adjacent to the port and within the hinterland. So that has the benefit where these port facilities and these type of activities with these very large size of components, they need quite a lot of land to do that storage and assembly. And at times you can have other industries cropping up in the near area, which have got a synergy with access to a deep water terminal. And we've got the benefit where a lot of the land is zoned for port-related uses. So developments can only happen if they have a link towards use of the port. Next one is the reduced carbon footprint. Having the closest proximity to the offshore wind zones reduces the amount of fuel burned by the ships, so it helps reduce that carbon footprint during development. We're also what we call a single port solution. So typically when these developments are done, they're split into 2 contracts. First contract is to do the foundations for the offshore wind turbines, and the next one is to do what we call the wind turbine generators, which is the turbine blades, the tower sections, and the nacelle units. So we've got sufficient size where we can do both of those activities at the one port rather than splitting them up between different ports. We've also got the capacity to meet the timeframes, which has been set by the Victorian Government. So the legislated offshore wind target is to meet 2 gigawatts by 2032, 4 gigawatts by 35, and then 9 gigawatts of offshore wind power by 2040. And lastly, we're government owned. We're a 100% state-owned entity. And so there's greater control that the government has in terms of the developments to meet their overall program of works, of which the port is one component. So to have a offshore wind generation, you need a port, you need the offshore wind turbines developed, and you need the transmission grid to get that power to a suitable location to transfer it throughout the Victorian grid. Our key design objectives and requirements, which are set by the Victorian Government, is that we must support wind farm developers for the installation of fixed foundation offshore wind turbines. There are there are 2 different types of foundations. You can have floating or fixed. Victorian water depths are suitable for fixed, so we are providing for that component, and the realisation of Victorian Government commitments to the offshore wind. We also need to provide sufficient space for the wind turbine generator and the fixed foundation units. So this is harking back to having a single port solution rather than spreading it out over multi-ports. And we also can't have any impact to the existing capacity at Port of Hastings. At the moment, about 30% of the state's liquid energy needs come through the Port of Hastings. So that's your petrol and diesel and aviation fuel. So it's a bit of critical infrastructure for the state, so we can't impact on that. So, Port of Hastings went through a pretty rigorous, or the state government went through a rigorous assessment to land at Port of Hastings as a preferred location. So we then needed to land at the appropriate location within the Port of Hastings, and also how big the terminal needed to be to meet the design requirements set by the government. So in terms of we put a number of lenses in terms of how we go and assess coming up with the size of the port and its location. And some of the key things that we look at is, first and foremost, the environmental impact, but then the operational and functional suitability, technical feasibility, which includes storage space and compatibility with the existing port operations, minimising changes to any sensitive habitats. And we also spent a lot of time talking with the industry, so those offshore wind developers, and with the government as to what did the industry need and what did we need to provide to make sure we were in line with the government and then their offshore wind aspirations. So going through that rigorous assessment with all of those different criteria, we then came up with a long list of 9 viable design options, which we then went and assessed in more detail. And then we progressively ruled out various options until we landed on one preferred option. And our preferred design option was really the only one option that met all the functional, environmental and technical requirements that have been set for us. So these are 8 of the different options that we assessed. Option 9 was the one that we finally selected, and I'll show you that in the future slide. So coming up with the final design option, we were looking at amount of reclamation, amount of dredging, navigational safety in terms of the alignment of the berths and bringing in ships and how that would be safely done. We also looked at the operational requirements, cost, and a whole number of different other attributes. And so working through all of those options, we then came up with the preferred option, and which the one that we're taking through the environmental effects statement process, which we will talk about a bit further on, and that is shown in the following slide. Good. So the proposed development is shown in this particular slide. So the different areas, in which we've got different colours, we've got the existing Old Tyabb Reclamation Area site. So that's the existing 25 hectares of land, which we propose to develop and put heavy-duty pavements over the top of. The green and the grey area, that is the area where we'll be reclaiming out into Western Port. So we'll be bringing in engineered fill from on-land quarries and building out into the water. The distinction between the green and the grey area is that the grey area that is what we call the key apron, and that is where the ships berth up against and unload the very heavy equipment, which form the components for the different turbines. And then the yellow area is the area of dredging. So what we need to do in that location, that specific location, is go and deepen the area of the existing seabed so that we can safely bring in the size of vessels that are required for the offshore wind campaign. And one thing of importance is that a couple of years ago, we put in what is called an EPBC referral. It's a referral that goes up to the federal government. And one of my colleagues, Natasha, will talk about that in more detail. Following submission of that referral, the government came back and requested we reduce the size of the terminal And so we've gone and done a substantial modification to what had previously gone in, and we've gone and reduced the dredging area, so the dredging footprint by 70%, and also reduced the reclamation area by 35%. So through a combination of hard work and really looking at the operational requirements for the terminal, we've come up with this substantially modified layout, which is a really positive outcome and came through a lot of work and based on pretty rigorous environmental studies that we will also discuss further on in the presentation. So I will now hand over to Natasha Reifschneider for the environmental assessment update.
Thanks, Peter, and good evening, everyone. I'm the Approvals Manager for the Port of Hastings Corporation. My background is environmental assessment, planning and approvals in Victoria. Thanks, Liam. This evening, I'll be providing an update on the environmental assessment process for the project. In Victoria, a major project can proceed. However, it's likely that for major projects, you may require an environmental effects statement to be prepared. And through that process, that helps regulators and the community understand the potential environmental, social, economic and other impacts on the project and really thoroughly test those impacts before a key decision is made. The first step in the assessment process is the referral, and in July 2023, Port of Hastings made that referral submission to the Victorian Planning Minister, and the Minister determined that an EES was required. Some of you may not be familiar with an EES or Environment Effects Statement. What an EES is really a very large report that explains the likely effects on the environment. So it looks at effects on animals, plants, water, air, noise, and nearby communities. And it also looks at what risks or problems could happen and ways that these things could be avoided or reduced. The EES helps the Victorian Government, experts and the community understand the full impacts of the projects before it's allowed to go ahead. It's not an approval, but it gives the Planning Minister and all the environmental information needed to help make a decision as to whether the project should proceed through other legislation. And with our project, given that it does require an EES, one of the first steps in that process is the release of the draft scoping requirements, which have been prepared by the Department of Transport and Planning. And these really set out the specific requirements that we have to assess for the project through the environment assessment process. Now, preparing the EES, which is where we are now, we're in the stage of the project where we get on with the work. This involves doing a whole range of technical studies that I'll explain in the next slide, doing community engagement and hearing from the community about what they might be concerned about or the values that they're aware of in the area. And that is all collated through the process. We also look at the impacts from the project and what we can do to manage those impacts. Following the preparation of the EES, that report goes on exhibition, and that's where the public gets the opportunity to read the document, ask questions, and make formal submissions on the project. And depending on the complexity and the level of public interest, the Planning Minister may appoint an independent panel to conduct an inquiry of the project, which we do expect to happen for this project. The panel then considers the submissions from the public, it holds a hearing and prepares a report making recommendations to the Minister. And finally, the Minister makes an assessment that outlines whether the environmental effects are acceptable and that is an assessment that can be then used for decisions under other legislation, including Commonwealth. So this slide here provides an overview of the technical studies that are a really important part of the environmental assessment process. Here we have 21 technical studies that are taking place for the VRET project, and all of these studies will be made public when the EES is placed on public exhibition. As you can see, there's a whole range of studies, and these are done by scientists, engineers and specialists, and they look closely at how the project might affect the environment, and they do their work to make this assessment. They're not guessing. This work is based on data, modelling and real-world observations, and this helps us all understand the potential risks and impacts and whether they can be avoided, managed and reduced. And these studies also are really important in helping guide the design of the project. For example, if the study finds that a noise issue might occur at nearby homes, then we go back and we look at ways we can refine the project to deal with that matter. And importantly, these studies give the government, decision makers and the communities confidence that the risks have been properly managed and mitigated. In short, technical studies are the real foundation of the EES, and the decisions are then based on facts and not assumptions through these studies. Today we'll be hearing from Chantal on onshore ecology, coastal processes, through David, and visual impacts Hayden will talk to. So that's three of the studies outlined on this slide. And alongside the state assessment process, the VRET project also needs to be considered under the Commonwealth Environment Protection and Biodiversity Conservation Act, or otherwise known as EPBC Act. This is Australia's national environmental law, and it applies when a project could significantly impact what are called matters of national environmental significance. For our project, this includes three things: Ramsar wetlands, which are internationally recognised and protected, listed threatened species and ecological communities, and listed migratory species. As some of you may be aware, Port of Hastings submitted a referral under the EPBC Act in 2023, which outlined a broad project area and a high-level project definition. And then in January 24, the Federal Environment Minister decided on the project in its previous form could not proceed. Since this decision, Port of Hastings has done a lot of work. We've gathered a lot of information on the environment, a lot of data, and really used that data to reshape our project and provide a much lower impact on the environment, as Peter outlined earlier. So now we've prepared a new referral, which is ready to be submitted to the federal government. I will now hand over to David, our Design and Construction Manager. Thanks, David.
Thank you very much, Natasha. I've got the pleasure of being able to run through a quick animation. It goes for about 5 minutes, and it's going to just run through the proposed construction methodology for the project. Thanks. So the Port of Hastings is set to play a key role in Victoria's renewable energy transition to a clean energy future through the establishment of the VRET project. And the Australian Government has declared an area off Gippsland in the Bass Strait as Australia's first and largest offshore wind zone, and you can see that on the screen. Now, VRET is ideally located about 190 nautical miles from the offshore wind zone within Western Port, where we have a deep water channel, and it's also very sheltered in location. The site itself is a very industrial site, as you can see. To the south, we have the Esso plant at Long Island Jetty, and to the north we have BlueScope. The area itself was reclaimed in the early 70s. So the OTRA site that Peter talked about was previously dredged material that was brought back on land. Now, in terms of the scopes of work, we've got the landside work, the dredging, the reclamation, and the quayside apron that was mentioned before. And at the start of the project, we need to set up our site offices, set up the entrances to the sites, and then we can start to import the granular fill to the site. And initially, we're going to use that granular fill to do surcharging. And that surcharging will assist to consolidate the existing ground and improve the bearing capacity. We'll also create a bund on the south side to enable access back to land so we can commence the dredging that you see here. Now, the dredged material will be beneficially reused. We'll bring that material back on site and we'll use it for the reclamation. As you can see, we've got silt curtains around the dredger. It's a backhoe dredger, a medium-sized backhoe dredger. That material is brought back on land and articulated dump trucks bring it into the reclamation. Again, we've got silt curtains around the reclamation. We'll create a northern access as well. You can see the dredge footprint, and you will also notice it's very localised. So up until Esso, it's deep waters, and we're just dealing at the project site itself. Once the dredging is far enough away, we can start the marine piling campaign. That piling is done with a crane barge. The piles are brought to the site with a breakbulk vessel into Western Port, transported onto service barges, which come alongside the crane barge, and we continue piling the quay wall. Besides the quay wall piling, which is done by marine, we also have a couple of dolphins on either side. They assist to moor the vessels, and we create a berth box of 740 metres, which allows 3 vessels to be able to moor alongside. And in front of the quay wall, we have what's known as scale protection, and that's to prevent disturbance of the seabed from the vessel's thrusters. So the stone is placed on the seabed to protect and avoid that. The reclamation and the surcharging is continuing on the land side. This is another ground improvement method shown, which is controlled modulus columns, CMCs, and that's where we inject cement into the ground, again, to improve the bearing capacity. As Peter mentioned, we have very large loads coming to the site, much higher than a typical port, so the ground has to be strengthened. Here we're showing the quay wall is being retained with sheet pole at the back and tie rods, and that helps to restrain the front quay wall from moving during the reclamation process. In the permanent state, we also have a lot of vertical and raker piles. You can see the raker piles, and they're tied in with a concrete slab over the top, which has a dual purpose. It takes the permanent lateral support of the quay wall, but it also takes the high loads of up to 30 tonnes a square metre for bringing in the components, etc. As you'll see, a lot of piling is required for this project. There's a combination of concrete and steel piles that may change as the design develops, probably more to a steel pile solution. There's services to go below the ground, and over the top we have a flexible granular pavement which can be easily maintained. These are some images of the port once complete. You've got your admin building, warehousing and car park at the back. You see the blades, towers, and you see an offshore vessel heading off with 4 fully assembled towers along with blades, nacelle units leaving Western Port. There's also a photo we'd like to just show you at the end. This is a monopole. This monopole is 8.7 metres in diameter. It weighs 1,600 tonnes, just to give you a bit of an appreciation of the size of the components that we'd be bringing to the port. You can get monopoles of up to 15 metres. So this, whilst large, they can get bigger as well. So that's why the port really operates as a marine facility. And once operational, there's very little coming from the land side. But during the construction phase, that's when the majority of the materials are coming from the land. Thank you. I'm now just going to pass to Dan, who will present on coastal processes.
Thanks, David. I'm Dan Messiter, Principal Coastal Engineer for Haskoning, and yes, we were tasked with undertaking the coastal processes investigation for the EES. Just a quick overview of what I'll discuss today. It's up there. Mainly focus on the high level points, the scope, the methods that we adopted for the study, and the existing conditions that we modelled, particularly the plume modelling that's created from the dredging, and some of the early findings around those studies. So this is some background of my qualifications. 28 years in primarily coastal, maritime and environmental engineering, with particular expertise in numerical modelling of ocean, coastal and estuarine environments, which includes a lot of dredge plume modelling, and was employed by the Queensland Port Authority as an expert in a peer review of the long-term dredge plume modelling to inform impacts on and management of dredging within the Great Barrier Reef Marine World Heritage Area. Obviously a sensitive site. Had experience on projects within Western ports since some of the investigations we undertook in 2014 for the port terminal that didn't proceed. But some of that experience and the information has been brought forward for this project. Experience in dredging projects around the mainland Australia, just not in Tasmania. So just a quick overview of the steps that we undertook for the coastal processes study. I guess the main point of the study was to characterise the existing coastal processes, the physical processes, the tides, the tidal currents, waves, and the resultant sediment transport that naturally occurs within the port. And going a little bit further than the sediment transport, but to actually have a look at characterising the geomorphology of the area. Further to that, the characterisation of the early work, then we took that forward to the plume modelling. So there are a number of methods adopted, including the review of past studies and historical information, hydrographic surveys, geotechnical conditions, an extensive data research and I guess collation and summarising the key points in that information. But along with that, the development and calibration of numerical models to test some of the observations that comes out of the conceptual understanding of processes from past studies and site information. And into those coastal processes models. So we had we have the hydrodynamics and then the sediment transport, which is driven by the hydrodynamics, and also the numerical modelling of the waves. So into those models, there is also a catchment model, which gives you the rainfall, runoff, and suspended sediments, and as inputs to the boundary conditions of that hydrodynamic modelling. So we also did site-specific sediment settling testing, where we took the actual dredge material that was likely to be produced and did some settling tests in the water from the port, which gave us a good indication of how the model should behave. Just to show you the extent of the model and some of the necessary resolution of the model, going from offshore to inshore, and some really high definition, high resolution modelling around the actual subject site. So as I said, the first step is to model and define what is happening at the moment, and verify that against existing data, so it gives you confidence in the numerical models to reproduce some of the scenario testing that is undertaken for the impacts of the dredging and the facility itself, and also the production and propagation of sediment plumes during the construction. So important to note with the waves, which is in the middle at the bottom, there is that there's no penetration to the site, essentially, of swell waves from offshore. So we're only really dealing with the wind wave climate. And important to note from the hydrodynamic is some of the very high tidal velocities which exist in the port, and particularly in the entrance area and close to the subject site. So the task of the plume modelling is obviously to take what the engineers describe as how this the dredging is going to occur, and come up with some representative numerical modelling of that process. And so there's a lot of work done around the source terms that were how that sediment plumes will be created by the particular plant that's going to be used. I mentioned the sediment velocity testing that we did, the laboratory testing. So what an important thing to understand is the dredge modelling looks at the numerical modelling, which models the suspended sediment concentration that's in excess of the existing ambient conditions at the site. And I guess an important thing to note is that where we were describing the physical outcomes of the processes, those would be taken on board by the marine ecologists in terms of assessing the impacts on the ecology. So some early findings of the hydrodynamic modelling showed there are some changes to the tidal velocities, but only very locally in the around the proposed facility. And if you zoom out to the entire port, those effects are actually very or negligible, basically, on the wider port area. So it's only really in the immediate vicinity of the facility where there's any change at all, and even that change is relatively minor. So this is some of the suspended sediment concentration mapping. So this is basically the 95th percentile, or there's only 5% of the time where sediment concentrations are higher than this over the 4.8 months of the duration of the proposed dredging. And so it basically shows the concentrations in the water column, and you can see that the strong tidal currents that exist basically confined the bulk of the dredge plume to the western shoreline, and there's very limited impact in the north or the upper north arm of the port. So some of this findings from the sedimentation, again shows that those high tidal velocities tend to confine any impacts to the western shoreline, and you can see some very minimal bed thicknesses of between 2 and 4 millimeters over the duration. And basically the sedimentation is very local to the site, and it actually occurs in naturally depositional areas or natural sediment sinks where deposition of fine material is expected and naturally occurs. Again, the job of the coastal processes is investigation is to describe the physical aspects of what's occurring, and in passing that information onto the marine ecologist to assess what the impacts of those physical processes are on the ecology. So I will now pass to Chantel, who will talk further about the onshore ecology.
Thanks, Dan. Hi everyone, my name's Chantel Steele. I'm the Environment Manager at the Port of Hastings Corporation for the Victorian Renewable Energy Terminal project. Today I'm here to talk to you about the onshore ecology study and some of the related technical studies that feed into that work. The scope of the onshore ecology assessment is shown here on the slide. Firstly, to characterise the existing ecological values, focusing of course above the high tide watermark, the waters and coastal areas below the high tide mark are the subject of the marine ecology surveys and studies. The second point here, to assess the potential impacts to those identified ecological values as a result of the construction and operation of the terminal. It's also to produce a native vegetation removal report to consider removal of any native vegetation. In this instance, that also includes the coastal and offshore native vegetation, so seagrass and the like, despite the fact that that's below that high tide mark. And then, of course, to recommend appropriate mitigation, monitoring and contingency measures to manage those potential impacts. As I mentioned, there's some related technical studies that feed into the onshore ecology work. Those are listed there. You've heard today on coastal processes already, and I'll also briefly at the end of my presentation touch on surface water and groundwater a little bit too. Thank you, Liam. So the area assessed for the onshore ecology assessment is referred to as the study area. That study area encompasses approximately 46 hectares of land. That includes the Old Tyabb Reclamation Area, or the OTRA site, Long Island Drive, which is the road adjacent to the OTRA, the coastal intertidal zone to the south of the OTRA area, as well as the power connection corridor along Barclay Crescent. We've undertaken some site investigations within that study area, and the Biosis is undertaking this work, they've determined that the quality of vegetation within the study area is generally low to moderate, and that's reflective of the fragmented nature of the local landscape and, of course, the historical and ongoing disturbances. And by that we mean the reclamation that occurred to construct the actual OTRA site, as well as some ongoing disturbance in the local area. The study area has also been found to support a threatened ecological community, so that's the subtropical and temperate coastal salt marsh. There's also some patches of native vegetation from around 6 vegetation classes. There's 6 species listed as threatened and protected under the state legislation. There's also some decom-mapped wetlands within the OTRA site and in the coastal intertidal zone. However, field investigations of the wetlands, those mapped wetlands, have shown actually that quite a substantial area of that modelled habitat is dominated by some high threat weeds. There's also groundwater dependent ecosystems, and by that we refer to ecosystems that are reliant on groundwater, and that could contain plants, animals, ecological processes or services. These are likely to be present in areas of coastal salt marsh and in the thickets of tall marsh and swamp scrub, particularly in the south of the OTRA site. And I've got an image shown here of the coastal salt marsh. That's the community that I referred to earlier. The habitat types that are largely present are in the form of wetland vegetation. There's some woodland vegetation, particularly along Long Island Drive, intertidal mudflats, of course, and some areas of non-native planted vegetation as well. So the site investigations that I mentioned also included some targeted studies, and has identified that the study area supports 3 threatened species. That includes recorded populations of swamp skink and glossy grass skink. Both of those species are protected under state legislation, but the swamp skink is also protected federally. We've also got records of the white-bellied sea eagle using the aerial space above the Old Tyabb Reclamation Area, also protected under state legislation. Monitoring for the swamp skink and glossy grass skink has been undertaken at the site, but also in adjacent lands to try and understand the connectivity and extent of the local populations. Further to those 3 threatened species, there's also suitable habitat for a further 6 threatened species. Whilst we haven't recorded those species, we have identified that there is suitable habitat that exists. So those species are the blue-winged parrot, white-throated needletail, grey-headed flying fox, fork-tailed swift, little eagle, and the powerful owl. In terms of early findings, you can see here on the right an image of the ecological features, most of which I just described before. So you've got up in the north end of the OTRA, there is a natural drainage line there, and some native vegetation. There's also some of the swamp skinks are present in that drainage line. Down to the south, in that pink box, that's the coastal salt marsh. The hatched area is the threatened EPBC community. In terms of the Long Island Drive, you can see on the left there's some fragmented native vegetation along there. That's that woodland that I referred to. And to the south of the OTRA, outside of the project area, but within the study area of the site, you can see that there's some extensive mangrove shrubland and some further coastal salt marsh as well. Unfortunately, due to the nature of the project, swamp skink and glossy grass skink impacts can't be avoided because we need to conduct habitat clearance in the areas where those populations are found for the terminal's operational area. Impacts to orange-bellied parrot are actually not expected, given the project area only includes a small area of low to moderate foraging habitat for that species. Similarly, impacts are not expected for blue-winged parrot, white-throated needletail, grey-headed flying fox, or the fork-tailed swift. And again, that's due to the limited presence of low to moderate foraging resources, but also limited dependence on terrestrial habitat for those species. That is, they're primarily aerial. The project will result in the direct loss of 1.3-ish hectares of coastal salt marsh, that threatened ecological community I referred to earlier, and that's shown at the area that I highlighted previously. The study area is also unlikely to meet the definition of important habitat for any terrestrially based migratory species. Of course, in terms of water birds, there's definitely some important habitat largely relating to the Ramsar wetland. A quick overview of some of the groundwater works that we've undertaken. The groundwater levels at the site vary between around 1 metre and 3.5 metres Australian height datum, and there's a general easterly groundwater flow direction towards the coast, as you would expect. The recharge of the underwater groundwater levels is predominantly from diffuse rainfall recharge, with discharge occurring mainly to the ocean, with some loss via groundwater pumping. So there's a pumping well, for example, directly northwest of the site. The groundwater salinity is fresh to brackish, or in real terms, slightly salty. For those of you who are not familiar, we're also undertaking some ongoing groundwater monitoring, and that will provide the data needed to inform the groundwater modelling that will be undertaken for the project to ascertain any potential impacts to groundwater from the project. In terms of surface water, I mentioned before there's a drainage line in the northern area of the OTRA site, and that is the primary drainage pathway for the upstream catchment to Western Port. Stormwater within the catchment is largely controlled by existing drainage lines, existing drainage conditions, and the most notable drainage feature is the southern saltmarsh area I referred to earlier again. That's actually a sedimentation pond that was constructed around the same time as the land reclamation to enable the water to discharge from the dredged material during that reclamation process. Modelling will be used in the assessment of impacts for the proposed layout of the terminal and used to determine the anticipated effects to surface water values that have been identified at the site. Structural and non-structural mitigation measures will be developed to respond to any of the identified effects in the project area. Just by way of explaining this figure here, so this is the project study area relating to the surface water.
Sorry, I think we've just lost Chantel. Sorry, guys, I think we're going to jump ahead now and move into visual amenity.
That's me. Can you hear me, Lyndall?
I can hear you. Yes, I can. And thanks, Chantel. Go ahead, Hayden.
Thank you. I'm Hayden Burge, Director of Landform Architects. I think there's a slide coming up that gives a little bit more about me. What I've been tasked to bring to this session is where we're at in the early stages of the landscape and visual impact assessment, and provide some of the considerations, the methodology, and some of the findings that we've found to date. In stepping through these things in a stepwise fashion, I'll outline the key features and what we know about the project that has the potential to contribute to visual impacts, define and outline how we've identified the investigation area for LVIA, summarise some of the viewing locations that we have considered and captured to date to be included in the report, and some of those locations that we're hoping to, I guess, further develop and bring on board with community consultation, and making sure that we are capturing areas that are of interest and importance to the communities. And just present some of the photo montages that we've developed in the early stages of the project that are assisting to define and develop the project, and some of the other studies that are assembling themselves in and around the project. If we can go to the next slide, please. A little about me. Bachelor of Applied Science from Landscape Architecture from RMIT, Landscape Architecture and Urban Design, a member of the Australian Institute of Landscape Architects and the VPLA, or the Victorian Planning Environmental Law Association. been practicing for just on or a little over 25 years now, and regularly am called upon to provide expert evidence in a range of forums on landscape architecture and visual impact assessment. So what I'll talk through is just some of the principles and methods that I've developed and have applied to this project as we see being required to the assessment. Sorry, and just before we get into that, so Natasha touched earlier on the draft scoping requirements that set out the matters that each of the technical disciplines are required to consider in assessing the project's impacts relative to those disciplines. So for LVIA, it's not to determine and identify each and every location that has the potential to view components of the project. What we've been asked to do and consider, similar to most projects of this scale, is to identify and locate the area, the potential for significant effects on landscape values in the vicinity of the project. Identify areas and locations where there's the potential for significant visual effects or impacts on nearby residents and communities, and we'll talk through how we've identified those shortly. And also identify the potential for cumulative impacts of this project in the context of existing infrastructure. So how do we do that, and how do we go about LVIA? So for me, landscape or visual impact is not based solely on the ability to see a project. LVIA is a measure or an assessment of a topic that it is quite subjective in a way, but do it and assess it in a way that can be considered objective and is useful to the approvals process. The method that I apply is based more on the UK guidelines for visual impact assessment, or GLV3, and it's one that's not matrix-based or numerical. And what I mean by that is we don't have an impact of 1.9 plus a visual impact of 1.4, which equals an overall score of 3.4, for instance. For me, visual impact assessment is not useful, and it's harder to justify or define in that way. Instead, I look at 6 criteria that are considered in assessing the overall visual impact of a project, and present them in a way that's hopefully useful for communities to understand, but also decision makers to consider or contemplate the project's impacts when assessing the overall project. The criteria include several features or criteria that can be measured or quantified, such as scale, distance, and viewer numbers, but also measure and balance those against qualitative considerations, such as what's the purpose or nature of the location where the view is impacted from. And again, coming back to the scoping requirements, what's the nature of the view and the potential for significant impacts on key areas, and also what are the features in each view. So the 6 criteria that we look at, firstly, are project features visible or not? So for instance, would they be screened or impacted or ameliorated by topography, vegetation screening, or buildings or other features in the view? What's the landscape change that the project will bring about? An example of that, I think, is the scale of change. So here the project is being inserted into an industrial area that's already designed and developed for these purposes, rather than converting greenfield or land in the green wedge zone or farming land into a use that's different to its current setting. Distance is the ability to or measure or capture the reducing prominence with increasing distance. And that is as we get further away from features, they become less obvious or noticeable in the view, and we can measure and consider that in the impact assessment. And we also use that to define the extent of the study area. The duration of the view is partly based on the nature or the location and the setting. So is it an area that you will spend a considerable amount of time, such as Woolies Beach foreshore, or potentially a marina setting, or that type of landscape useful setting, or Hastings foreshore reserve? Or is it a short-term view that's occasional along a path or a roadway or similar setting? For this project, it's also useful in considering the potential for significant effect of the towers being transported out from the VRET site out to the offshore wind farms and their final destination. Landscape character and sensitivity is partly what's the location the view is from and what can be seen in the view, and then finally the number of viewers. Next slide, please. So what do we know and what have we considered in the initial investigations? What we know about the site is that it's located at the northern end of Western Port. It's located directly on or within land that is a strategic port and has been identified for these purposes and is owned accordingly. And for the transport of the towers in an upright position, which is a key consideration for our assessment, is within the existing shipping lanes that's shown in blue, or the channels, shipping channels, which are shown in blue on the map on the right. In terms of cumulative considerations and cumulative impacts, is that it's located to the south of the BlueScope Steel facility and north of Esso. What that means in terms of visual and cumulative is it's not spreading the geographic extent of industrial uses along the shoreline. It's located within and hemmed in by those facilities. That also has contributions to the nighttime lighting environs, and the lighting contributed to by those two facilities and other uses around the site. The shipping lane or transport route, sorry, we're there. Considerations for there, if we can just go back to the previous slide, please, sorry, is that for this assessment is what's relevant to the shipping and the transportation lane is that, as we understand it, is that once the transportation vessels enter the shipping lane, is that they won't stop anywhere within the port waters. So that's the purple outline and the blue dashed area. Once they depart, they'll continue through without stopping until they reach their destination. As I understand it, the current number of outward bound vessels, so ships with the towers in the upright position, is approximately every 10 days is the current modelling. My assessment, I've considered this to be every 7 days or one shipping movement a week. So that's the frequency and the duration. If we go on to the next slide now, thank you. So the assessment is what we've considered is what's happening within the terminal area and where what is the potential for a significant visual impact to be brought about. Previous slides and presentations have shown the layout and configuration of the quayside area. For visual impact, it's the potential for to be able to see the towers when they're in an upright position. So that's when they're at their most vertical and potentially most obvious from many locations. That'll be limited to the quayside area immediately adjacent to the berth pocket and for vessels alongside the berth pocket itself. So they'll be transported from the quayside onto the waiting vessels. The ships themselves will, the towers themselves will initially start out at heights much lower than 200 metres. But what we have designed, based our assessments on, is towers that are up to 200 metres in height. So that's in several years' time where where we expect the towers and the technology to be. So it's future-proofing the assessments that picks up that incremental change in advancements in technology. Next slide, I've already talked about the transportation routes if we can. So I'll run through and see if we can make up some time. So coming back to defining the study area and zones of visual influence and where the key project activities are likely to be, is the study area I define based on the height of the tower and how far away you might need to be to reasonably see or view the project infrastructure. So I've defined the study area as being 11.5 kilometres from the VRET site, which is the yellow circle seen towards the top of the screen. The reason for it being confined to that area as 11.5 kilometres is that that's where the towers will be upright most of the time within the facility. 11.5 kilometres from a 200 metre height tower is the distance where they would be about 1 degree in the vertical field of view. So as we get further away, they get incrementally smaller. And 11.5 kilometres is, if you can see the tower in full, that's from the base to the tip, they'll occupy 1 degree in the vertical. So across that scale bar in the bottom of the view, each one of those notches, for instance, is 1 degree in the vertical. The next zone in from there is 4.6 kilometres, and at that distance, let's just go back to 11 kilometres will be about the ship on the right-hand side. I'm wondering if Liam's able to circle just the ship on the far right-hand side at about bearing 355 degrees. That one there, just below the mouse, is about what the scale that we'd expect to see a tower at 11.5 kilometres if it were clearly visible without any intervening vegetation, topography or other features. Then as we step into the next ship on the right-hand side is what we'd expect to see the scale of the towers alone in an upright position at about 4.6 kilometres. At that distance, that's about 2.5 degrees in the vertical field of view. And then the near field zone is 2.3 kilometres, which at that distance I would expect a tower to occupy 5 degrees in the vertical field of view. That's based on simple trigonometry and the parameters of human vision. So that's sort of scale and perception over distance. Next slide, please. So within the study area, landscape character and sensitivity areas that we've defined landscape character is we've defined 8 landscape character units. These have been identified or based on features and factors such as topography, vegetation, whether it's existing, natural, modified or cleared through farming and other uses, underlying land use zones and overlays and schedules to the various planning schemes that help identify and assist and guide development and desired outcomes for those areas, as well as the use of the land itself. So whether it's within a township, a national park area, or areas of open water, recreational facilities, etc. The relevance of the 8 landscape character units to the assessment, is it assists to consider what is happening in, so firstly, the selection of viewing locations to be considered and assessed in the direction of the project, but also what is the nature of the view in the direction of the project from those areas. And in some instances, those character units also establish what the amenity expectations might be for users in those areas themselves. Next slide, please. So we've identified a number of viewpoints located from land-based locations around from the areas surrounding the project. We're continually adding to these and refining them. All of the locations are currently shown coloured in blue or green on the land-based areas, and I've identified some areas that I'm particularly interested in on French Island that we do want to test with the community at French Island. So those locations are the Pinnacles, which I understand to be a key and prominent attraction on the western side of the shorelines. It's also elevated with clear views at particular times of the day towards the project. And the second location is the Fairhaven Caravan Park. The next slides will talk through the visibility of the project through photo montages that I've selected to start guiding and helping and informing the project both internally and through conversations with others and stakeholders, and certainly the preceding sessions we've had at roundtables. So the 4 locations one is from the marina, Hastings Marina and Jetty near the centre of town. The second location is the Tyabb Cemetery, which I'll talk through those features shortly. Jack's Beach Foreshore Reserve along the northern edge of Crib Point, and from the end of Thompson Avenue and on Cows. Sorry, next slide if we can, please. So the first location is the Hastings Jetty and Marina. Key considerations for selecting this viewpoint is that it's about approximately 2.6 kilometres from the terminal and the location of the upright towers, 2.9 kilometres west of the closest point on the shipping lanes and the transport route. The marina is a location that's familiar not only to residents, but also visitors to the area, users of Pelican Park Recreation Centre, the skate park, and it's also a destination or one of the key parking areas for the Hastings Foreshore Reserve to the north. So it's central to town, it's on the edge of town, and it's got views in the direction of the project. Go to the next slide, please, Liam. So what we do for when photo montages and where they're most useful for me is firstly through the use of a 60-degree enlargement. So this is a 60-degree horizontal that's selected from the centre of that panorama. And we use this for all photo montages for a couple of reasons. But most importantly is it gives us 60 degrees, gives us a good frame of reference to consider scale and prominence of the upright towers over varying distances. This viewpoint, particularly for this location, it was also chosen, in addition to it being familiar with locals and visitors, the masts on the sailing vessels moored in the nearby marina and the light poles along the end of the jetty give us a good frame of reference to also understand the scale of the towers in an upright position over varying distances, and we can use those across the whole assessment as a point of reference. If we can go to the next view, which shows a photo montage of the towers superimposed in the view. So what this shows us is the scale of the upright towers at the height scale location that we would expect to see them being located along the quayside areas, but also shown along on the awaiting vessels for departure. Key considerations for the assessment here is that at 2.6 kilometres, these towers in an upright position fully visible would be about 5 degrees in the vertical field of view. What we're seeing in this setting is that the towers are less visually obvious or prominent than masts on nearby vessels, but they're also roughly twice the height of the light poles and lighting along the jetty in the marina. What we've also done to show here is that the maximum number of towers, both in the berth pockets, being up to 8 or 9, that may be visible at any one time, as well as a number of those on the waiting ships. And as I said before, to be conservative, we've shown them all at 200 metres in height. So this is just a sense of scale and perception of the project over distance. If we go to the next viewpoint, which is from the Tyabb Hastings Cemetery. This location is about 1.1 kilometres west of the terminal area and 1.5 kilometres, so that's the inside edge of the terminal area, and 1.5 kilometres west of the berth pocket and the quayside areas. The areas within the terminal site where sorry, I don't know what that note means. West of the cemetery is a small cluster of dwellings that are set within existing vegetation. They're slightly further in distance to this viewpoint, that are similar to the trees that are seen in the left-hand side of the view, between generally north to northeast. Also of note here is that when you're on site is that the towers in the Esso facility, the bulk storage vessels in the Esso facility are screened by existing vegetation. So it gives us some guidance there on the capacity of vegetation to screen. We go to the next view. There's my note there. So this is the existing view, and if we just skip quickly to the next one, it shows the photo montage of the towers over this distance. Why we're not seeing much of the towers is that we've got a low rise that drops down to the shoreline, but more importantly, it's the proximity and scale and height of the existing vegetation that surrounds the margins of the cemetery and also much of the area further to the west of this location. Just still on that view is that another key point in the cemetery and for other areas where there is this type and scale of vegetation is that even we are at 1.1 kilometres, is that as we're closer to vegetation, it becomes much more prominent and more capable of screening views in the direction of these towers. Next view, please. The next location I chose for a photo montage to start assisting the project and the communities is Jack's Beach foreshore area. It's located along the northern edge of Crib Point Township. It's also along a trail network that connects into Hastings Township via Warringini Park. This location, there are clear views across Western Port towards the terminal site, which is about approximately 4.6 kilometres to the north and about 3 kilometres west of the transport route. From this location, there's also clear views across Western Port with mangroves in the foreground and Sandstone Island in the background. If we go to the existing view again, just to get that setting in contrast, again, we've enlarged it to a 60-degree horizontal field of view, which focuses on where the site will be. The tanks for scale and distance and prominence and locating where we are. Sorry, the tanks in the Esso facility are just visible on the left-hand side of Shark Island there at about bearing 15 degrees. If we go to the photo montage, thanks, Liam. Sorry to catch you out there. What we're seeing there is the scale and prominence of these towers at 4.6 kilometres. Again, we've shown the maximum number of towers up to 200 metres in height. At 4.6 kilometres, and if we go back to the slide around scale, bring our minds back to the slide around zones of visual influence on scale over prominent distance, they'll be about 2.5 degrees in the vertical field of view if they were fully visible. Although the towers will be an obvious addition to this element, what we're seeing to this viewpoint and locations along the shore or foreshore is that they will be a background element to Sandstone Island and not as dominant as we might expect if they were fully visible. Next and last slide is a location relevant to the centre of township of Cowes. The view I've selected here is taken from the Anzac Memorial right at the northern end of Thompson Street. It's elevated, it's easily accessible, and a view that is likely to be taken in by locals on a frequent basis, but also visitors to the area as they on and off from the ferry, but also walking along the shoreline. This location is also one that I consider to be conservative in that it's clear and not obstructed by light poles and banners and flags and street trees and other features that are typical of urban settings that can impede or alter views. Key features from this location is that the VRET site will be about 16.5 kilometres in the distance at around, I think, bearing 345, so roughly central to that view. At this distance, they'll be 0.7 degrees in the vertical field of view if fully visible, but part of them will be tucked in behind that nearby headland. The closest point and relevant to this viewpoint and Towers community and other locations along the foreshore is that from here, the transport route will be about 2.1 kilometres in the distance. And the towers, as we saw in the earlier scene setting image, was that the towers will be about 5 degrees in the vertical. So if we click to the existing view, I won't dwell on this, but if we add the next slide, which shows the ship or the transportation vessel at its closest point that I can identify to this location. So what we see here is that the upright towers will be highly visible. There's no other conversations around that, and that they will be visually dominant at this distance. But in terms of the overall impact assessment, and what we must consider is that the current timing suggests that as the vessels round the heads, depart the site round the heads and head off to their final destination, they'll be visible for about half an hour to 45 minutes, but increasing as they in prominence as they come around the heads, pass across the front of Cowes and then exit. Again, they'll be visible once every 7 to 10 days, so half an hour, 45 minutes every 7 to 10 days, and then they'll be in their outward cycle. The inward shipping movements we do consider to be less obvious and noticeable, partly because all the component parts will be coming in, laying down and horizontal in bulk transport vessels, so they won't be tall, and that their obviousness will be not dissimilar to the existing ships that access the port currently. And I think that is it for me.
Thank you, Hayden. And thank you to our speakers for your presentations tonight. I hope everyone got something out of what was shared. During this presentation, there's been a lot of questions asked. I'm hoping we can get through as many as possible, but we may not be able to cover all of them. We will be focusing on the ones that, because there's been several that have been upvoted, so we will be focusing on those because I can see there's a strong interest in covering those. Now we have about 30 minutes left to cover off on our Q&A section. And any of these questions that we may not get to, and I do acknowledge that there's quite a number in relation to marine ecology, we won't be able to cover all of the marine ecology questions tonight, and I will acknowledge that our next online webinar, which is going to be on the 10th of July, we will definitely be able to attend and participate. We'll be able to answer those questions in that session. So if you have a queued question in regards to marine ecology, we won't be able to answer that tonight, but we will follow that up. To start off the session, start off the number of questions, however, I do want to pose a specific one, and it's to Natasha and to Peter as well. It's in relation to our EPBC referral. So my question is, Peter, if you wouldn't mind just starting and providing us with a response. When are you resubmitting the EPBC referral, and if so, what is the timing around that?
Yeah, okay, thanks, Lyndall. So, yeah, look, a lot of work's gone into preparation of the new EPBC referral. We expect to have news very shortly in terms of submission and when it may be made public, but I'm not in a position to actually give any timelines. It's a bit it's a Commonwealth process, but when we can update everybody, then we will do.
Fabulous. Thanks, Peter. I'll now get into our questions. Peter, it's the question direct for you now. We're getting quite a bit around shipping, so we will kick it off with a question in relation to what kinds of ships are going to be used to ferry parts to and from the terminal, and how many ships do you, or how many ship trips do you anticipate per week?
Right. Okay. Thanks again, Lyndall. So, firstly, once this project goes operational, and they start the construction of the offshore wind farms out in the Gippsland offshore wind zone, so we expect approximately 130 ships per annum, so commercial ships per annum. Now, that is a combination of ships that are delivering turbine components from manufacturers in overseas locations, and also what we call offshore installation vessels, and they're the vessel that is picking up components, going out into the offshore wind zone, installing them, and coming back for more components. Now, just by way of reference, in terms of the number of ships that we currently have, the commercial shipping ships that we currently have, it's around about 130 ships per annum. Although we are seeing, because we're predominantly fossil fuels, there is a bit of a diminishing of trade as the reserves out in the Bass Strait diminish. So, but yeah, 130 current ships at the moment, and approximately 130 ships per annum once our development is finished. And just to put a bit of context around that, the number of ships going into Port Phillip Bay, commercial ships, is around 3,600 per annum.
Fabulous. Thanks, Peter. Just on that note, just in addition to that, once the build stage of the offshore wind farms mature, do we envisage that this number will drop off? And do we have a bit of a time frame around that?
Yeah, so look, the current timeline for the Victorian Government for offshore wind is they want to get 9 gigawatts in by 2040. So at that stage, so the offshore wind vessels would sort of tail off by that time. Now, it could be that it becomes quite an economic and reliable source of energy, and so there's certainly other developments possibly for offshore wind that could extend beyond the 9 gigawatts. So it's a bit hard to sort of predict exactly when the use of the terminal will diminish for offshore wind, but it certainly won't be before 2040.
Fabulous. And just staying on ships for the moment as well, this is more of an environmental question, and I may also call on Chantel if you do want to make a comment in relation to this as well. But as far as environmental impacts are concerned, we understand that the terminal is being built within a sensitive marine Ramsar site. So just in terms of ballast water monitoring and controls, just how environmentally friendly and what kind of controls might be in place to manage these types of ships coming in?
Yeah. So management of ballast water is incredibly important. In the past, with poor practices, marine and invasive species have been transferred from other ports around the world where they've picked up water to put into the vessel, and then it's been discharged into other ports, and it's introduced these new marine species. Present day, however, there are very strong protocols around ballast water management. So when a ship is out in the middle of the ocean, he has to dump all of his ballast water and put in new ballast water that doesn't have all those marine pests, because it's done in incredibly deep water out in the middle of the ocean. So in any port now in Australia, it's very highly regulated through the federal government and probably the state government as well. So lots of procedures and requirements to ensure that that doesn't happen.
Thanks, Peter. Now, we need to move on to design, and this is actually design and construction. David, if I can just call on you. So we've got a question in relation to the assembly requirements for the different wind farm developers. Are they fundamentally different? And how will these requirements impact on the port design and operation?
Yeah, look, it's a very good question, and the answer is yes. Every OEM and proponent has a different idea of how they're going to lay out the facility, what type of crane they're going to use. In terms of tower assembly, some do it at the quayside, whereas others lift it onto the offshore vessel and pre-assemble onto the vessel. So we have to come up with a facility that is flexible and can, deal with loads across the quay wall, deal with the required laydown, and be able to be moved around and changed depending on the OEM's requirements or proponent's requirements. So the answer is yes, but I believe we have a facility that can accommodate, changes.
Fabulous. David, this is also, I'm going to stay with you.
Nice.
And also Peter might want to add a little bit as well at the end. Now, we have significantly reduced the dredging footprint in relation to the previous EPBC referral and the work that we've done to refine the design. So in terms of doing this, has there been any concessions made or limitations on vessel access to the site? For example, the wind turbine vessels or jack-up barges? And how would this affect the cost or timing of the offshore wind turbine installations out in the Bass Strait?
Yes, I think up to the Long Island Point, as we talked about earlier, the channel is already naturally deep up to this point, so it is very localized dredging. The berth box, we've done what is a discrete event simulation, a DES study, and we've been able to optimize the dredging requirements and feel comfortable that we will not affect vessels in terms of coming in and coming out. So I don't know, Pete, if you want to add to that, but we're comfortable that whilst we've reduced the dredge requirements, we feel comfortable it's not going to affect the operations.
Yeah, so just to add a little bit, David, spot on. There's a couple of things that we've done that has been enabled us to reduce the dredging footprint. First of all, we've done some detailed bathymetry investigation. So bathymetry is mapping of the height of the seabed. Secondly, we've done a lot more detailed work around the size of vessels and the amount of water depth that they require. And the third one is the discrete event simulation, or we also call that a time and motion study. And it's enabled us to, instead of dredging down to the depth that we had proposed originally, we will adopt what we call working the tides. So Western Port has very high tide, like it's got a 3.5 metre maximum tide. So I guess say compared to Port Phillip Bay, it's only about maybe 1.8 metres or so. So it means we've got more flexibility to bring vessels in on not the lowest of low tide, but if we can defer the vessel till it's sort of like a little bit above the low tide, that's allowed us to significantly reduce the dredging footprint.
Yeah, so to Peter's point, anything above mean sea level, which is about 1.7, 1.8, is actually uninhibited. So we're comfortable with that.
Great, Peter. I've got another question for you. Now, there's two elements to this question. It relates to the cost of setting up the facility. Yep. So what is the cost to set up, or what costs have we considered in terms of building the terminal? And what is the delivery model that's being considered in terms of the setup of the terminal?
Right, okay. So first of all, with the cost, we've gone through a rigorous process to work out the estimated cost of the terminal, but I'm not in a position to divulge that figure. That's commercial in confidence. And then the second thing is the delivery model. So the delivery model, I presume, is about how we procure a build contractor, so a tier 1 contractor to come and build the project. So that's currently under assessment at the moment, and so not in a position to advise.
Thanks, Peter. Now, we do have a number of more construction-related questions, but I do want to give a number of our other approvals and environmental questions that have also come through a little bit of airtime. So we will come back to those construction questions in the chat. Natasha, I'll pass this question to you. Now, in terms of our EES process, is the State Minister obliged to take on public feedback when considering our studies?
Sure, thanks, Lyndall. So the answer is yes, because through our EES, we have a number of parts of the project where we're engaging with the public, such as tonight, where we're hearing what you have to say about the project, and we're responding to those questions, concerns and comments in our EES. And all of that is documented in the final report. There's also the opportunity for the public to make comment during the exhibition process of the EES that I outlined earlier, and the panel process where by members of the community can make representations to an independent panel. So there's lots of opportunities for the public to be involved and help really provide feedback and shape the project.
Thanks, Natasha. What is the time frame for the EES, and when does the Port of Hastings expect to start construction?
So construction is expected in 2027. So if you work back from that, we're looking at late 26, early 27 for the EES process. That's a broad time frame, but that's where we're at the moment, Lyndall.
And this is related probably to our climate change assessment. And this might be something we'll need to take on notice, but I will pose a question to you. Natasha, has an assessment been conducted on the carbon footprint associated with the construction of a terminal? And an estimated, is there an estimation provided for how long it may take for any kind of wind power generation to offset this impact? Now, again, Natasha, you may not be able to answer that question. Feel free to also, this might be something that Peter can jump in, but if you'd like to respond first, Natasha.
Yeah, thanks, Lyndall. So that's not a requirement that we've been asked to respond to in the scoping requirements that are set out in the way we develop the environment effects statement. So it's not something that we're assessing at this point in time.
Peter, did you have a comment?
Yeah, no further comment to that.
Okay. So Chantel, can I bring you up on the screen to ask you a couple of ecology questions?
Sure.
Hi, Chantel. So will the swamp and glossy skink populations be relocated or taken into captivity for breeding purposes, as a suitable habitat elsewhere probably has already have local populations of these species? Can you respond to that?
Yeah, sure. Thanks, Lyndall. So I guess in terms of the phase that we're up to in the assessment process, we're still quite early on. So understanding exactly the population dynamics of those two species. In terms of management measures such as relocations or breeding purposes, we're not yet at that point to be able to discuss, I suppose. There's certainly elements of relocation or things like that that we will be considering, but at this point we're not quite up to that stage of the assessment just yet.
Okay. Thanks, Chantel. And in relation to the 1.3 hectares of coastal salt marsh that was discussed or mentioned in your presentation, is there any offsets that are going to be considered for that?
Yeah, so in relation to that community, it's a Commonwealth protected community, and those communities are only required to seek offsets in the case that that community, in any ecological community, when it's endangered or above. This particular community is listed as vulnerable, and therefore no offsets are required. There will be compensatory measures and things like that that the project adopts, whether that's in relation to coastal salt marsh specifically. I'm not yet sure of at this point.
Thanks, Chantel. And just acknowledging as well, we will be talking further in relation to marine ecology and some of those impacts associated with that in our next session. So in terms of getting back to Peter, again, we've got another question in relation to, it's more of a why Port of Hastings is the most suitable. So this is an upvoted question. So what is the Victorian Government strategy in relation to the selection of the ports? And does it also require Oyster Cove or also consideration of Bells Bay in Tasmania? And what consideration has been given to Barry's Beach Marine Terminal in relation to its proximity to the offshore wind zones in Bass Strait?
Good, thanks, Lyndall. So look, a good start for people wanting to find out more is implementation statement number 3 and implementation statement number 4, which are documents prepared by Offshore Wind Energy Victoria. And if you type them into Google, you can find those implementation statements. So Offshore Wind Energy Victoria, or OWEV for short, are running the overall program, of which the port is one component. Now, OWEV has determined Port of Hastings to be the most suitable location and the preferred location, and there are some reasons given within that document. However, it does also refer to the potential for other ports to play a role within the offshore wind industry, and places like Geelong, I think that's Oyster Cove, I'm not so familiar with Geelong, but assume it is, and also Bell Bay are definitely two other locations that could potentially play a role. And exactly what role is sort of more to do with that broader Offshore Wind Energy Victoria to decide. We're concentrating on the Port of Hastings. As I said in the presentation, a number of reasons why we are the preferred location, proximity to the offshore wind zones, amount of area that we've got available for these very intense land area intensive sort of projects, deep water channel, etc., etc. Now, in terms of the last part of the question, which was around Port Albert or Corner Inlet at Barry's Beach. So yeah, people call it different names. So look, there's a small port located there at the moment, which has got great proximity to the offshore wind zones and definitely quite a lot closer than Port of Hastings. That, however, has got very shallow depths, water depths, and so there'd have to be a very significant amount of dredging to be done to allow these offshore installation vessels and delivery vessels, and significantly higher than what would be required for the VREP project. So it is expected to play a very key role, however, as an operations and maintenance port. So these offshore wind projects need to be continually maintained, and so it's likely that crew transfer vessels will be based at Barry's Beach. and will continue for the lifetime of all these offshore wind projects, of which each will have a lifetime of about 30 years. So a very important and prominent role for Barry's Beach.
Fabulous. Thanks, Pete. Are you able to share if there's any similar global examples of offshore wind assembly ports that the Victorian Government or Port of Hastings has been using in terms of, or referencing in terms of developing both the offshore wind strategy and the terminal design?
Yeah. So in terms of, the offshore wind strategy more lies with OWEV, but in terms of the port facility and making sure it's, fit for purpose and it's not oversized or undersized and has suitable flexibility for the future, absolutely. We've done extensive research into offshore wind ports, and typically you find quite a few in Europe, which is where the offshore wind industry really kicked off around the world. But there's also good examples in the United States and also Taiwan and a few other countries. So yeah, we've got consultants on board helping us with the design and the time and motion study I spoke about before. And these consultants have largely got a lot of international experience with offices in these locations. So, and we've talked in extensive detail with the offshore wind proponents that have the feasibility to build a development in the Gippsland offshore wind zone. So in answer to your question, yes, many talks and many late night calls and early morning calls with European and US counterparts.
Fabulous. Peter, I want to talk to you about local benefits. So there's been a number of questions put forward in relation to what are some of the local benefits for the Hastings region that might come about as part of this project, in particular local jobs.
Yeah, so there are two distinct phases. The first one is when we go and construct the terminal, and then when we go operational. So in terms of construction of the terminal, you'll probably have around 250 jobs, and that will go for an approximately 2.5 to 3 year period or so. So whether so that labour will be under a tier 1 contractor, so the contractor who's chosen to build the project, and I'm very hopeful there'll be a lot of use of the local labour in the Mornington Peninsula and the Hastings area. There'll also be all those add-on sort of secondary in terms of material suppliers. We need quarry material, we need concrete, we need cement, we need steel, and we need equipment to go and build it. So I'm sure that's going to generate an economic boost within the local community. And then after we go operational, and operational is sort of for the next up to 2040 and hopefully beyond, then there's going to be a lot of work being done at the terminal. There won't be that same number of jobs at the actual terminal itself, but there'll be need for a whole range of different people, like even from catering to, the people that, we need the cleaners, we need people to supply secondary steel work, to do assembly works on the site, to provide bolts, and it's a whole list of different add-ons that having this sort of industry going through the Port of Hastings will bring to the local area.
Peter, I'm going to stay with you, and then we may finish up with one question to you, David, but we are coming close to time now. Peter, how long will the VREP project take to build, and how long will it be used for the assembly of offshore wind turbines? And then I also have a second part. What will happen to the site after the wind turbines have been assembled and installed in the Bass Strait?
Yeah. Okay. So in terms of construction, it's around 2.5 to 3 year period or so. We could well have a staged opening of the terminal, so we get part of it sort of operational before the end of the entire construction period. And then Victoria has got legislated targets for 9 gigawatts to take us up to 2040. And then potentially there'll be additional gigawatts that will be, that there'll also be business for beyond those legislated targets. So at least up to 2040, but quite probably beyond. Now, this is a fairly big investment by the state. And so after offshore wind does finish, then the state would look to use the terminal for trade. So it will want to keep utilising the terminal. However, our planning approvals that we will get for the terminal is for sort of largely for offshore wind components. So if there was any change in use of that facility, then planning approvals need to be sought, and it's got to go through a pretty rigorous planning approvals for any change of cargo. The cargo that we will be able to take in is the offshore wind. We also hope onshore wind components and some other ad hoc shipments of oversize over mass cargo. But yeah, if the government looked to change that, planning approvals would be required with public consultation included in that.
Great, thanks, Peter. Another construction question, Peter, I think you will be able to answer this, but David, if you could pipe up if you've got a response. Will the construction be a 24-hour process, or will it stop at night? And will the operations be 24 hours?
So look, I'll answer once it goes operational, then I'll hand to David for during construction. So once this facility is operational, it'll be 24-hour operations. And David, I'll hand to you for construction.
So in terms of construction, there's probably 3 main activities that would still occur over night time. The first one is the dredging. That will run 24 hours, and that's over around an 8-month period, 7 to 8 month period. The import of the granular fill due to the volume will be 24 hours. We'll look at the vehicles to make sure they're low noise, etc. One of the activities we won't be doing is piling at night, obviously because of the noise. And the other one that I believe will probably happen at night too would be the concrete works. You know, there'll be some concrete pours that go into the night, but we'll try to limit noise clearly.
And just a little bit to add to that, once we do go operational, these components are so big, they can't go on roads or anything like that. The equipment components come in by ship and they leave by ship. So it's only very peripheral secondary truck movements what we might have once we go operational. However, during construction, there definitely will be truck traffic in the local area with quarry material and concrete and other materials.
Now, we've actually come to the end of the presentation, and I just want to acknowledge there are a number of other questions that have been posed in relation to design and very specific construction-related questions. Where we can respond, we're going to, and also there's some questions in relation to traffic and local roads. Now, where we can, we're going to set up a FAQ on our website and attempt to sort of respond to some of these questions here. But we do need to close proceedings now at 9 o'clock. So I do want to thank everybody for attending. Again, thank our presentations. And as I mentioned, we will be using our website to respond to some of the unanswered questions here. But also, I just want to call out to anybody who is on the call very interested in staying in contact with us and also posing their questions directly to us. Please reach out. You can see our email address here and phone. We're happy to take your phone calls and questions and open to your feedback as well. So please reach out with any questions that you would like a direct answer on. So we're also, as I mentioned, we're also hosting 3 more sessions in July. Where we're going to be presenting more of our preliminary findings around marine ecology and specifically to water bird studies. We're also expecting to have an update in relation to our project design and assessment process. So I do encourage you, if you can come in person, our first session will be in Hastings on Saturday the 5th of July. Our second will be in Flinders on Tuesday the 8th of July. But again, we will be online and answering questions again on Thursday the 10th of July. So as I mentioned before, thank you again to our speakers and for your participation and attendance tonight. We absolutely do appreciate your interest in this project, and we welcome your feedback on tonight's session. Good night, everybody.